Eu tenho a honra de aqui abrir a palestra do Dr. Scott Halstead. Dr. Scott Halstead, please. Yes, Dr. Scott Halstead. Dr. Scott Halstead, are you talking Portuguese? I will make your presentation in Portuguese, okay? Okay. Ok. O Dr. Scott Halstead é professor adjunto do Departamento de Medicina da Universidade Health Science, em Bethesda. E ele vai falar para nós, fazer a apresentação sobre febre amarela, 17D, milagre na Rua 66. Yellow Fever, 17D, Miracle on 66th Street, New York. O Dr. Scott Halstead, para quem não conhece, ele é doutor em medicina pela Universidade de Colômbia, atuou em vários países do mundo, mas, sobretudo, no Japão, Tailândia e Coreia. Ainda participa de comitês nacionais e internacionais, consultorias, conselhos consultivos, periódicos, e contribuiu com mais de 225 artigos científicos publicados em revistas científicas. E nos Estados Unidos, foi cientista-chefe em pesquisa de doenças infecciosas da Naval Medical Research em Bethesda, cientista sênior do Departamento Molecular de Microbiologia e Imunologia da Universidade Johns Hopkins e diretor de pesquisa e orientador sênior na Pediatric Dengue Vaccine Initiative, ou chamado PDVI. Foi diretor de Ciências da Saúde da Fundação Rockefeller e é atualmente consultor dessa instituição. Dr. Scott Halstead, ele sempre atuou na área de vacinas, sempre teve uma atuação muito forte na área de vacinas. E eu me lembro, e participamos juntos, no desenvolvimento da Children Vaccine Initiative, que foi em sequência, aconteceu em sequência da CIREVA, Organização Pan-Americana de Saúde. Depois surgiu o Children Vaccine Initiative, com discussões amplas por mundo inteiro, sobretudo na Organização Mundial de Saúde, para motivação e advocacia do processo das atividades de desenvolvimento de vacinas e vacinação. Children Vaccine Initiative deu origem à atual Gavi, Global Vaccine Immunization, que desenvolve atividades de vacinação nos países mais pobres do mundo. E ele esteve conosco em 1987, na ocasião do 50º aniversário da introdução da cepa 17D no Brasil. Em 1987, tivemos uma reunião internacional sobre febre amarela e ele foi o conferencista maior dessa reunião, apresentando o trabalho e a atuação da Fundação Rockefeller no desenvolvimento da vacina febre amarela. E eu queria dizer que hoje, 30 anos depois, estamos comemorando hoje 80 anos da introdução dessa cepa no Brasil. Então, é um ano realmente muito importante para ser comemorado, porque não é assim, são poucas instituições que podem comemorar essa efeméride. Nesse processo, é importante dizer, dos inúmeros pesquisadores da Fundação Rockefeller, que participaram no desenvolvimento da vacina febre amarela, Dr. Hugo Smith, que trouxe a cepa da vacina desenvolvida na Fundação Rockefeller, e lá eles desenvolveram um pequeno estudo clínico vacinando os laboratoristas do laboratório onde foi desenvolvida a cepa foram os primeiros a receber a vacina e que mostrou, então, a alta soroconversão e considerou-se pronta para ser feito o desenvolvimento seguinte para o escalonamento e a produção dessa vacina. Em 2 países, na verdade, foi na Colômbia e foi aqui no Brasil. Mas, Dr. Hugo Smith, aqui no Brasil, teve a cooperação e a colaboração de um brasileiro chamado Dr. Henrique de Azevedo Pena, que nós homenageamos, acabamos de homenagear, dando o nome ao Dr. Henrique de Azevedo Pena, ao novo centro nosso integrado de biofármaco, reativo diagnóstico e desenvolvimento. Dr. Henrique de Azevedo Pena, Dr. Hugo Smith e todo o grupo, então, nós aqui desenvolvemos toda a parte de escalonamento da vacina, a adoção de lote-semente, pela primeira vez na produção de uma vacina, foi adotado a tecnologia de lote-semente. E aqui os grandes estudos clínicos para consolidar, então, finalizar o desenvolvimento da vacina febre amarela. I just talked that you came here 30 years ago in order to commemorate 50 years of 17D introduction in Brazil, and you're coming back after 30 years of that time. And then that Hugo Smith and Henrique de Azevedo Pena, the Brazilian fellow, that together worked to have scale up of this vaccine and big field trial in Brazil and consolidate this vaccine. This is an honor for me to introduce you, and you have the floor for your presentation.
Okay. Does this work? Yeah. So, Dr. Homa, thank you so much. Perhaps you've given my whole lecture. I can sit down. So I'm really very delighted to be here. As Dr. Homa said, I was here 30 years ago to celebrate the 50th anniversary of the introduction of 17D. It's a real privilege to be here on the 80th. If I'm around at 100, invite me back. It's not likely, but who knows? Quien sabe? So I'm here to talk about what I call the miracle at 66th Street. Now, you've all seen the Hollywood movie Miracle on 34th Street. So when I was thinking about what to say about yellow fever vaccine, the word miracle always comes to mind. So as I'm going to show you, this is a miracle that occurred at 66th Street. Now, this is the actual miracle. I mean, the vaccine is a miracle, but Hugh Smith bringing this vaccine to Rio de Janeiro in 1937, when only a month or two before, he and Max Tyler, this is the famous Hugh Smith, who with Max Tyler did all the experimental work that resulted in this vaccine. A couple of months before this picture was taken, he and Max Tyler had both inoculated themselves with this brand new thing that they had discovered in the embryonic cell cultures that they were passing virus in. So he got on a ship, came to Rio, brought the seed virus. He actually put that virus in embryonated hen's eggs, which is a very important step because that made it grow to quantities that were commercially viable. So how did the miracle happen? Well, the miracle starts with the story of yellow fever, which is in itself a rather amazing and miraculous story. And the story begins with, of course, Carlos Finlay in Cuba, who observed and thought that a mosquito that he actually identified was somehow related to the catching of yellow fever. And so during the Spanish-American War, the United States Army formed a commission and appointed Walter Reed, who was one of the very few microbiologists in Army uniform, to come down and form a commission. And he talked to Carlos Finlay, and Carlos Finlay actually gave him the mosquito we today call Aedes aegypti. And so Reed did the famous experiment, you remember, in the divided house, where one side had the soiled bed clothing and the other side had infected mosquitoes. He infected 3 different volunteers. They all got yellow fever and survived. That's a miracle. At any rate, almost immediately, the military surgeon of the U.S. Army in Cuba, William Gorgas, literally invented Aedes aegypti control and started implementing it in Havana. And within a few months, Havana, which had had yellow fever cases for 300 years, had no more cases. So March of 1905 and beyond, William Gorgas had stopped yellow fever transmission. And he made this statement as early as 1902, a statement that sadly we have to still say, I hope it'll be true. I look forward in the future to a time when yellow fever will have entirely disappeared as a disease to which mankind is subject. And then your Oswaldo Cruz took his inspiration from Gorgas and began controlling yellow fever in Rio. And then Gorgas was assigned by President Roosevelt to be in charge of sanitation in the Panama Canal, and he controlled yellow fever, which had killed up to 30 or 40,000 when the French were attempting to dig the canal. So here they are, Walter Reed, General Gorgas, when he was the Surgeon General of the whole Army during World War I. Here's Carlos Finlay, and here's your Oswaldo Cruz. So shortly before the war, the Rockefeller Foundation founded a commission. Well, it was founded, and then Wycliffe Rose took a trip to the Far East and learned that all the countries in the Far East were terrified that the Panama Canal was now going to open a direct route of shipping and would bring yellow fever to Asia. So you'll hear this again. The fear that yellow fever would get to Asia is what actually encouraged the Rockefeller Foundation to form a commission, and Gorgas agreed to belong to that commission. And here he is. This is General Gorgas. This is a man that everybody who works on yellow fever and dengue and Zika and chikungunya should know. I wonder if there's anybody in the audience. This is Dr. Carter. Dr. Carter was a public health surgeon working in the bayous of Louisiana during the days when they had yellow fever outbreaks. And he's the man who found that there were 2 different incubation periods. If you personally went and visited a house where there was yellow fever going on, you might get sick 5 days later. If somebody from that house came over to your house, you might have yellow fever in your house, but it would be 15 days later. Now, what's the difference between 5 and 15 days? It's the 10-day extrinsic incubation period. Walter Reed could never have succeeded, and this is the reason why Finlay failed, is everybody thought, well, you let the mosquito feed, and then you immediately let them feed on a susceptible subject. It doesn't work that way. You have to hold the mosquito for the extrinsic incubation period while the virus goes from the gut to the salivary gland. So this is a very important man. Here's Wycliffe Rose, who was actually a mathematician and appointed by John Rockefeller to head the International Health Board. Now, we had to have World War II get finished, and when at the end of the war, the Yellow Fever Commission went to Guayaquil in Ecuador. It was selected as the first place for to apply Gorgas's methods of vector control. And so that was followed by a whole series of campaigns, many right here in Brazil. And then in 1925, knowing that yellow fever existed in Africa as well as the Americas, the Rockefeller Foundation set up a laboratory to actually isolate virus and prove that the American and the African viruses were the same. And that's when the CB strain was isolated. A CB had a very mild case of yellow fever. So when the Rockefeller people put this yellow fever in imported Indian rhesus monkeys, because they found that the African monkeys wouldn't die with yellow fever, this CB strain coming from a very mild case of yellow fever killed all the monkeys. In fact, it killed 3 of the Rockefeller Foundation researchers, one of them Noguchi. So here's the meeting in Guayaquil. This is the beginning of the Rockefeller Foundation Urban Yellow Fever campaign. It started with a meeting in Guayaquil, and this is the Rockefeller Foundation Yellow Fever Commission. Here's the famous Dr. Noguchi, actually in Africa. And here's one of the Rockefeller Foundation offices here in Brazil. So by 1928, people in Colombia and then here in Brazil began to see that there were yellow fever cases that occurred where there was no Aedes aegypti. And so then began this search for yellow fever in different parts of the Americas. And a really important thing happened around 1930, which was that Max Tyler, who was actually at Harvard, not at the Rockefeller Foundation, discovered that if he inoculated yellow fever virus intracerebrally into mice, the mice died. So he, by that act, created a assay system for assaying the presence of yellow fever virus. You could recover it, and also for measuring antibody. You could put antibody in the mouse and then inoculate or incubate antibody with the virus and then inoculate the mixture into mice. So this was a very important discovery, and in fact resulted in Max Tyler being awarded the Nobel Prize in 1951. A lot of people think that he got the Nobel Prize for discovering yellow fever. It turns out that the Nobel Committee has never given anybody a prize for a vaccine, or at least a viral vaccine. He got his prize because of discovering the mouse as a laboratory tool for working with yellow fever, and it turned out to be extremely important. So in 1931, we invented the viscerotome and began the real search for urban yellow fever, which is actually first described and proven by another hero, Fred Soper. So here they are. This is what, if you guys were all a little bit older, this is how you would have worked on yellow fever. Get on a mule and go out into the country. And here's the viscerotome over here. And here's the bureau established right here in Rio to monitor yellow fever cases all over the country. I wonder if you have something as good. I wonder if you have as many beautiful women in the office. So here's Fred Soper, another one of the heroes of yellow fever story. And this is what Fred Soper said a long time ago. Jungle yellow fever may be the more natural form of yellow fever endemicity, and urban Aedes aegypti transmitted yellow fever, an exotic form maintained with more difficulty than the jungle type. So the story continued when in 1928, the Rockefeller Foundation opened a laboratory at the Rockefeller Institute, which I'm going to show you. It's the Rockefeller Institute in New York that's at 66th Street. The Rockefeller Foundation had no buildings of its own. So in 1930, Max Tyler had moved to the Rockefeller Foundation and began these studies of attempting to grow yellow fever in the laboratory. Meanwhile, Sawyer, another Rockefeller Foundation officer, developed a yellow fever vaccine. What he did is he took something like the French neurotropic strain, a virus that had been highly passaged in mice, and gave it to, they were losing people in the laboratory. There were quite a lot of deaths due to laboratory-acquired yellow fever. So he discovered this process by which he took immune serum from humans that had survived yellow fever and mixed it with the French neurotropic virus, or something like the French neurotropic virus. So you give the virus in this arm and you give the serum in the other arm. And that worked. It actually produced antibodies and protected people, but it was very cumbersome. So here it is. This is the gate right here at 66th Street. And this is what the Rockefeller Foundation laboratory was located in this building at the Rockefeller Institute. Of course, those of you who've been to New York know that this is York Avenue, and beyond the Rockefeller Institute is the East River. So pretty nice place. I wouldn't mind working. Nice apple orchard. I've got fruits and vegetables here. So here's what the gate looks like today. This is just taken a short time ago. You can see the gate hasn't changed. It's still at 66th Street. If you stood at 66th Street and looked east, you'd be looking right at this gate. Of course, this is now the Rockefeller University, no longer the Institute. So you wonder, what was virology like in the 1920s? This actually, it turns out to be Dr. Noguchi's laboratory, and it's up there in Spanish, so I suspect this is his laboratory in Yucatan or someplace in Mexico. Pretty nice lab, really. I wouldn't mind working there. I've read a lot about Noguchi. Everybody says he was a mess, but this lab, he must have straightened up. So here are the key leaders at the Rockefeller Foundation during all this period of 20 years of yellow fever research. Fred Russell started in 1927. This is Wilbur Sawyer, the man who gave the first yellow fever vaccine. And he was very upset that he didn't get a Nobel Prize, because he felt, quite rightly, that this had been a foundation effort, and they had decided way back in the early 1930s to invest in the yellow fever vaccine. When they got one, they brought it to Brazil. They manufactured it here. They manufactured it in New York. But Nobel committees have their own ideas. So here's the first description of yellow fever in tissue culture. Now this is tissue culture like you guys have never seen. You take mouse embryos or chick embryos and you mince them up with scissors, put them in a petri dish, and then flood it with salt solution. And then you put it in an incubator. But they managed to pass this as CB virus, all these different passages, 18 passages in cultured embryonic mouse tissue. Now the interesting thing about this passage is that yellow fever at that time, if you put it in monkeys, the CB virus, it killed all the monkeys and they got a very severe hepatitis. 18 passages in cultured embryonic mouse tissue caused this virus to lose its visceral tropism. No longer killed monkeys by peripheral inoculation, it killed monkeys by intracerebral inoculation. So it had maintained neurotropism. And so it did through 58 subsequent passages in minced chick embryo. And so Tyler and Smith in desperation said, let's get rid of the nervous tissue. So they actually cut off the chick embryo's head and then dissected the spinal cord, and then they grew yellow fever for 160 different passages. That's 2 or 3 days to allow the virus to grow and then pass it on and on. No antibiotics. I mean, it's really heroic. Anyhow, in vitro passage 114, we lost viscerotropism and neurotropism. When I came down here 30 years ago, I had talked to Hugh Smith on the telephone, and he was telling me what it was like, because he was the guy that had to go in and every passage in tissue culture, they would inoculate mice to see whether the virus was there and whether it was killing mice. And he went in one morning, and the mice were all alive. And he said, "Oh my God, we've lost the virus." But when they let the mice grow up a little bit later, they then challenged the mice with hot strain of yellow fever, and the mice all survived. And so they said, "Oh my God, something really important has happened. The virus has lost its neurotropism, but still retains its immunogenicity." So the incredible thing is that of all the different lines, they had different lines in parallel. Only one out of the 6 passage lines showed this miraculous mutation. So here they are. Here's Max Tyler and Hugh Smith. And this is what I've just described to you, this rare, stable mutant. Max Tyler, at some years later, attempted to redo all those passages to see if he could obtain 17D again, and he didn't. So this is, when I said a miracle, I'm not kidding. This is a miraculous mutation, and there are many people in the audience who know a lot more about all the different amino acids and the different parts of the genome that have changed. It's a very complex change. Anyhow, it is and it was a miracle. So they promptly, I mean, really within a matter of months, inoculated themselves. Now, Max Tyler had already received the Sawyer vaccine, so he was immunizing an immune control. But Smith was susceptible, so they all survived and developed antibodies, and they knew that they had a virus. So in January of 1937, Smith got on that ship and came here to Rio, where he produced, as I say, in 7-day-old chick embryos, passages 205 to 287, made 40,000 doses of yellow fever vaccine, which he then went out and it actually tested in some of the, they were having yellow fever, they were having jungle yellow fever in 1937, like they are today. And by the time he left, almost a year later, the Brazilian facility had produced 600,000 doses. So here's what the yellow fever vaccine used to look like. For many years, while it was produced by the Rockefeller Foundation, here's what vaccine delivery looks like in those days. Remember, every vaccine had to be given by an individual syringe. It had to have an individual needle. And so they had these holders for the syringes, the needles, so they could be sterilized, and then you'd stick the syringe on. Very elaborate thing, but they were vaccinating thousands of people. Pretty amazing. So here's what mass vaccination looked like in the 1930s. And by 1938, they began to notice that there was younger children who began to develop encephalitis after different passes. At the beginning, of course, they got this virus. It's passed 200 times, and then they kept passing it. Every time you want to have a new batch of vaccine, they just pass more. So they finally discovered that some of the lots of passes vaccine were no longer producing antibodies, and B, some of these children were actually developing encephalitis. So right here in Rio, they adopted and developed, and we've used this ever since, the so-called seed lot system for all of the live attenuated viruses that are licensed and used all over the world. We use the seed lot system, which was discovered right here. So what do we still not know about yellow fever? That's the big question. I'm gonna give a talk tomorrow about what we've learned about how dengue virus protects, dengue vaccine virus protects or doesn't protect. It may be related to the 17D story. For years and years and years, all the focus was on antibodies. One of the things that yellow fever vaccine has always done is it produced very low titers of antibodies. So you really had to believe in antibodies. But more recently, we've begun to discover the importance of T-cell immunity. So a couple of derivative questions that on the surface don't seem to be related to the 17D story, but actually probably are. And these are what I would call some of the big unanswered questions in yellow fever research that people aren't even, frankly, attempting to answer. Why did urban yellow fever go to America and not eastward across the Indian Ocean to Asia? And why has the American jungle yellow fever not re-urbanized? So here's the home of yellow fever. As you know, it's a zoonosis, a very complex zoonosis. There are 3 or 5 genotypes, depending upon who you talk to. And the genotypes, there's a separate genotype here in West Africa. There's a Central African. There's a East African, but it's not East African because it doesn't actually go over to the East Coast. And each of these has produced, but the genotype that actually left and took this route across the Atlantic Ocean was the West African genotype. And we know that occurred around 300 years ago. And the incredible thing is that it re-sylvanized. It jumped into a jungle cycle. But this route for a virus that's so widely distributed in Africa, it's amazing that this route has never occurred. If I was giving you a different lecture, I could tell you about chikungunya or Zika, which have similar zoonoses, similar distributions in Africa, but they have both made it out the east side. So here we are, 3 African genotypes. Only the West African genotype is transmitted by urban Aedes aegypti, which is a mosquito that evolved in Africa and had to be brought to the Americas. So the Portuguese or whoever who brought mosquitoes and slaves brought yellow fever mosquitoes and slaves. And this is the mosquito which urbanizes, the one that's giving you so much trouble right here in Rio de Janeiro. So this is probably when this happened, and it entered an American sylvatic cycle, which is extremely complicated. I mean, there are many marsupials, not primates, that are involved. And the one thing we can say about the American sylvatic cycle is it's not very old, and we know that it's only 200 or 300 years old as compared with Africa. When the Rockefeller Foundation went to Africa, they caught wild African monkeys and inoculated them with yellow fever. They were all solidly immune, and if they had a susceptible monkey, it wouldn't get yellow fever. So you bred a whole population of monkeys in Africa that, like the HIV story, which are genetically resistant to yellow fever. The American primates and others are not. So why did the pandemic yellow fever never cross the Indian Ocean? Well, this is Scott Halstead's theory. I'd be happy to see somebody, somewhere, look at it and work on it. It's possible that the Central African yellow fever genotype, which does not urbanize into Aedes aegypti, but causes yellow fever, but it causes yellow fever like jungle yellow fever causes yellow fever in Brazil. This whole geographic cycle, zoonotic cycle, essentially blocks the West African Aedes aegypti from reaching the East Coast. You know, the East Coast of Africa is full of Aedes aegypti. Chikungunya and Zika and dengue all coexist on the East Coast of Africa. So, as I say, no yellow fever on the East Coast of Africa, no yellow fever in India. Now, the reason why this is important is because well, let's finish this. Why is the American sylvatic yellow fever not urbanized? Look at the extent, geographic extent of that. American jungle yellow fever has been successfully introduced into the urban cycle in South American towns and cities, has not been successfully introduced. And is it possible that the American jungle yellow fever virus is so poorly adapted to grow in Aedes aegypti that it cannot be urbanized? And that brings us right back to Fred Soper, who was a very smart guy and very insightful. And that's sort of basically what he's telling us for something that he wrote about 1934. So happy 80th anniversary, 17D. Don't forget, a lot of work to be done. I was talking to Marcos at lunch about, wouldn't it be nice if we could make yellow fever a vaccine virus that grows in something that's easy and cheap, like Vero, but it ain't going to happen unless you sort of recapitulate some of the steps that Max Tyler and Hugh Smith took, where they used the monkey, the rhesus monkey, as a model, because it is a model of, and of course you have to take your vaccine and vaccinate monkeys and then challenge them with a wild-type yellow fever virus. I understand that there's not much enthusiasm for working with wild-type yellow fever virus in Brazil. But anyhow, that's a challenge. The other challenge is people really should think about this question. I mean, I've lived for a long time. And the story that I've heard almost always is, oh my God, jungle yellow fever has started up in Brazil and Colombia, Peru, wherever, and we're going to have an epidemic of yellow fever. Well, it's never happened. I mean, there's got to be a reason why it didn't happen. It's like the reason why does yellow fever never reach the East Coast of Africa? And what is there about the Central African zoonotic cycle that has adapted that virus so that it does not grow in Aedes aegypti? So this is all a story of adaptation, complex adaptation of a virus that proved to be useful as a vaccine virus. I would submit that yellow fever is still adapting and creating challenges to all of us to solve. So thank you again for the invitation. Appreciate it.
Aceita receber questões, esclarecimentos e outros comentários que forem feitos pela plateia. Está aberto para isso. Portanto, doutor Reinaldo, será que poderia pegar o microfone ali? Ali, doutor Reinaldo. Thank you very much for your presentation. Very nice, straightforward, just putting together all the information in simple way.
Could you understand?
And a development which is considered one of most important development, using different technologies, incorporating new technology and innovation in the process of development and production. I think this is recognized as one of the most important development. But Dr. Reinaldo?
Thank you, Dr. Halstead, for your presentation. And we have some problems to be solved yet on the yellow fever vaccine. And the main problem is the serious adverse events that have been discovered in about 20 years ago in Brazil and the United States. So this created a problem for our, because it was not totally vaccinated against yellow fever because of the serious adverse events, visceral tropical disease in vaccinated people. So we don't know the cause yet. We have no idea. And we established recently a partnership with the Rockefeller University to try to find out the cause. We imagine that it could be a genetic predisposition from the host. So it is a partnership with Rockefeller University. Who knows, we can complete our job, improve the vaccine safety. And this is a comment. And the question is about the hypothesis of dengue protecting against yellow fever. Could you say something about that?
Right. You know, yellow fever, dengue, Zika, and about 80 other viruses, Japanese encephalitis, all belong to the flavivirus group. More remote is hepatitis C, even rubella. Don't forget rubella. When I was in Hawaii, the lab I built in Hawaii, I always said that's the laboratory that rubella built, because rubella vaccines that were just coming out. And turned out to be very easy for a dengue virologist to work with rubella, because everything, you know, hemagglutination, inhibition, everything's the same. The only reason why I mentioned rubella is because everybody is so mystified by Zika that's causing birth defects. But there is another virus in that superfamily, the flavivirus superfamily, rubella, which has done that. So it's maybe not as unique as you think. So anyhow, one of the attributes of the flaviviruses that we all know is that they share a lot of antigenic structure of their envelope protein. So when you're infected with any one of these viruses, you build a lot of antibody, some of which is functionally protective. The Japanese encephalitis vaccine trial in Thailand, reported by Hoke and the New England Journal of Medicine, occurred in a population that was developing dengue hemorrhagic fever, and they found that the JE vaccinated children had a lower incidence of dengue fever. So there is some functional evidence. As you remember, when I was at Yale, I inherited 120 monkeys from Joe Melnick, who had just left Yale to go to Texas. And I was at a brand new building, just like this, brand new building at Yale, and they had a monkey facility on the roof. And so I had just come from Thailand, and I knew that 2 different dengue infections in sequence was the cause of severe dengue. So I started to recapitulate that in monkeys. It turned out to be a lot of work because 2 combinations of 2, 1, 2, 1, 3, 1, 4. There are 12 of them, 12 combinations. And so I inoculated all those monkeys over a period of 3 years at different intervals. And when I was finished, and I went to the University of Hawaii, I gave them to Max Tyler, because Max Tyler was at the Rockefeller lab at Yale. And so Max did the experiment that he's always wanted to do, and the experiment that everybody in the dengue and yellow fever field has been talking about for years, which is, if you have hyperendemic dengue, does that protect you against yellow fever? Because that's what seemed to be different about Asia from, say, the Americas. So Max took my monkeys that were, all tetravalent immunes, and inoculated them with a CB. They all died, but they died at a much longer interval. So his conclusion was, I've just told you about the JE vaccine story, is that there was partial protection, in this case, dengue against yellow fever. I've thought about this issue for a long time, because I've known about that experiment for a long time. And it occurred to me that every population with hyperendemic dengue still gives birth to lots of young susceptible babies. And there's always a huge susceptible population. And that would have been true in India or any place else. So I've wandered around the world for years thinking, well, this cross protection isn't the answer. And that's why a few years ago I was asked usually I don't write about yellow fever. I was asked to write a chapter on yellow fever. And when I looked into it, I realized that's really interesting. Yellow fever in the history of mankind has never made it to the east coast of Africa. Never. And then I realized that if it did, Asia would be gone, because it's chikungunya, the minute it gets to the east coast of Africa, it's across the Indian Ocean. Zika went across the Indian Ocean. So I think there's something more complicated. But anyhow, to get back to your question, yes, I think there is some degree of cross-protection between a number of members of the flavivirus family. Since I've got the microphone, I've got an audience that's captive. Please do the research to tell us if Zika infection, if a prior dengue infection is a risk factor for any outcome of Zika you can think of, whether it's congenital Zika syndrome or whether it's infection of the throat or salivary gland or the reproductive gland. I don't care what the endpoint is, but what we need to know is whether a prior dengue infection is a risk factor. If it's a risk factor and is statistically associated with an outcome, then we're beginning to have some biological evidence that maybe dengue antibodies do indeed enhance or change the course of a Zika virus infection. So look, this is really important. I don't know if anybody reads anything that poor old me ever writes, but I did publish a paper in EID just a couple of weeks ago in an editorial in Lancet Infectious Disease where I asked specifically this question: what is the biological evidence that Zika is enhanced by dengue? We need to know, because if it is, it has enormous implications for dengue vaccine, for Zika vaccine, for everything you think of. So in my emerging infectious disease paper, I actually described an experiment which is very simple, which is a case control study. But you have to start off by just collecting let's say, look, women or babies that have congenital Zika syndrome. The freezers are almost certainly filled with sera from these women while they were pregnant or the time they gave birth. Those sera, of course, we know that the patients had Zika because the virus is isolated or whatever. But what we need to know is, do they also have antibody? And I couldn't listen to the discussion this morning about serological problems in the dengue and Zika, but don't be afraid of testing somebody who's just had a Zika infection to see if they have IgG dengue antibody. Just a simple indirect dengue ELISA will tell you. If you have a Zika infection and it's your first Zika infection in your lifetime, you're not going to have any dengue IgG antibodies. If you've had a prior dengue infection and now you have a Zika infection, for this very reason, they're both flaviviruses. You're going to have a marked anamnestic response to the B cells that are pre-existing. That gets us started. If dengue is enhancing all of the congenital Zika syndrome, then there ought to be 100% of mothers who gave birth to a congenital Zika syndrome baby who have dengue IgG ELISA in their serum collected sometime during pregnancy or just after pregnancy. So, Dr. Holm, I'm going to charge you with the responsibility to make sure that, because this is silly. We're going on. I'm sure you're reading the same literature I am. Just 2 weeks ago, there was a big splash in Science, wasn't there? Somebody come up with a mouse model where you have increased incidence of Zika disease in dengue immune mice. Well, that's all very good. But look, I'm the guy that discovered the two antibody business. And I didn't do it backwards, I did it frontwards. I started with humans. And we had evidence from human beings that a prior dengue infection was a risk factor for people who went on to develop severe disease. That's what we need. We need evidence from human beings. So I've made this trip all the way down to Brazil. Now, all of you who've ever made that trip from Washington know it's a long trip. You don't get much sleep. Anyhow, so please make my trip to Brazil worthwhile, and somebody go out there and get a few congenital Zika syndrome, and let's find out because if dengue is not a risk factor, we shouldn't be wasting a lot of time. Just think of the money that people are spending on mouse models, monkey models of Zika enhancement by dengue antibodies. Probably a lot of people right here in the audience that are doing that. It's okay, but if you have an established biological phenomenon, then you certainly ought to use whatever laboratory techniques you can use to try to understand how it works. We still don't understand how antibody-dependent enhancement of dengue infection works. You want a challenge, there's one. Anyhow, sorry to go on, but...
Thank you. Está aberta para... como é que chama? Esqueci.
Leda.
Por favor.
So I'm Leda Castillo from the Federal University of Rio de Janeiro. Thanks for the nice talk on this historical overview. And I would be curious to hear from you, what do you think are the future trends for yellow fever vaccination in terms of vaccine platforms, vaccine geographical strategy, and so on?
I'm going to give a talk tomorrow specifically relating what we've learned from the Sanofi dengue vaccine in humans and how that applies to other flaviviruses. Yellow fever vaccine belongs to a nice family of empirically derived vaccine viruses, first by Edward Jenner. Of course, he didn't do that on purpose. And then yellow fever really was next. Measles, mumps, rubella, varicella. Japanese encephalitis, I worked with Dr. Yu Yongshin in China, and so I've got to know him, and I don't know if you've ever read that story. It's just like the Max Tyler story. Years and years and years of passing. You pass it in this host and then that host and backwards and forwards, but he ended up just like Max Tyler did with an amazing vaccine. It's everybody, you know, as long as I've been alive, everybody said, "Oh, the best vaccine that ever existed is yellow fever 17D." Well, I think the SA14-2 is an equal miracle. And at any rate, those heroic stories should both encourage people, because the thing that dominates with Tyler and Dr. Yu is tenacity. And as I was, you know, Marcos and I were just talking at lunch about how can we improve yellow fever vaccine, because now we've got this two funny things. We've got the viscerotropic and neurotropic reversion phenomenon, and we still have the fact that we have to have embryonated eggs, and it's a heck of a pain. So the one thing I hope you learn from what I say tomorrow is that we're not going to solve this with fancy-dancy coupling together of different genes or proteins. The thing that characterizes all these successful viral vaccines is that it's the whole virus. It's the whole measles virus. It's the whole rubella virus. It's the whole mumps virus, the whole yellow fever virus. And that turns out to be really important, because you need to present to the immune system all of that complexity. So if you make a new yellow fever virus, you better start off with the whole virus. But you know, you guys are about to be famous, I think, because I think the Butantan dengue vaccine is going to be everything that we ever hoped for. And the guys at NIH did that by just knocking out 30 nucleotides from the C' end. I mean, will that work with yellow fever? Who knows? But it's worth a try. It knocked the virulence right out of dengue. And that, you know, if you follow that story, all those individual viruses have been put into human beings over and over and over again. So they don't just have safety data in monkeys, they have safety data in humans. So if you want to invite me back, I'll help you to oversee a rediscovery of yellow fever. I really think it would be very nice to be able to grow this virus in vero cells and be able to scale up and scale down as you need to. You know, we're not going to get rid of jungle yellow fever. It's going to, and it's all over Africa as well. So I probably didn't answer your question at all, but.
Alguém mais? Alguma outra pergunta? Por favor? Não. Eu quero perguntar, may I ask you one question related with the vector? In Brazil, the yellow fever is maintained because sylvatic yellow fever. No? We don't have it. Since 1942, any human yellow fever. So no yellow fever involved with the Aedes aegypti transmission, only sylvatic. Now, what do you think there in Africa? They have a human yellow fever with Aedes africanus involved. So the maintenance of yellow fever there is virus maintained there in circulation by the African.
Well, it's just the West African genotype.
Yeah.
Only the West African genotype can be urbanized, that can be transmitted by Aedes aegypti.
Yes.
So the other 3 or 4 genotypes, the one in Central Africa, which is transmitted by Aedes africanus, for example, cannot be transmitted. I mean, when I say it cannot be, it has not been. I mean, this is the complaint I have as a scientist, is that I would say everybody in the yellow fever field feels that studying jungle yellow fever is like the third rail. You know, you're going to get electrocuted. But the evidence, as you say, since 1942, is that jungle yellow fever has had an independent cycle, and it has never spilled over and caused large urban outbreaks. So I think the evidence is strong, but if you look at who has done research, well, there have just been a very few papers, and when they do research, of course, what they do is they take the jungle virus and then they put it in to Aedes aegypti, and more or less the few experiments that are published show that the virus does grow. So, but that's either the wrong question or the wrong answer, or there's something wrong about it, because if you have all this epidemiological evidence for years and years, then there's got to be some better model. And one of the problems with Aedes aegypti models is somebody takes an Aedes aegypti, you know, that's been domesticated for 20 years, and then that'll be what they use. Well, maybe that's not the correct Aedes. So I think you've got to give some careful thought. But I would say for the big-time virologists in the crowd, you know, there are a lot of important genetic differences between West African urban yellow fever, which you might have to get from West Africa, and sylvatic American yellow fever. And I'm sure that's all described in the literature. I don't happen to have it in my brain. But somewhere there have got to be changes that are really impeding this virus from growing in Egypti in a biologically reasonable way. So I think that there's some very important, and then I would say the same thing is true about the Central African strain. Why doesn't it grow in Aedes aegypti, and are those two linked? Is it the same genetic block? So I know a lot of people say, well, I don't want to work on that because if you take the fear out of the population that we won't get yellow fever vaccination anymore. Boy, I think that's a poor reason to ignore a really important scientific question. Anyhow, you've got lots of jungle yellow fever in Brazil, so you have ample reason to vaccinate you. In fact, I think you better start thinking, what is our strategy for protecting against jungle fever, yellow fever, rather than just saying, let's protect all the children, which is presumes that you're protecting against introduction in an urban outbreak. So it seems to me all these hunters and the picnickers and everybody, there ought to be sort of way stations on your highways saying you can't go anymore down this road unless you've had, you can show me your yellow fever certificate.
Yes. Yeah. Another question, if may. Dr. Reynaldo already addressed it, but we have a big question related with the 17DD or 17D strain vaccine because of severe adverse reactions. So it was considered 20 years ago the most effective and most safe vaccine, but now we have evidence that there are some severe, few, rare, but some.
I agree.
I just
I agree, but it's still, you know, it's thousands of people are vaccinated to get one, so it's still pretty.
Yes. Do you think that there is possible to have some biomarkers or something that we can find and preventively avoid these severe events?
Yeah, that's, of course, that's what you'd hope for, isn't it? But the biggest problem I think you've got is you don't have a model. You don't have a model. Without a model, you're really crippled.
Yeah.
I know that they've recovered the virus from many of these viscerotropic and neurotropic diseases, but they never. I don't recall that we learned much from.
Yeah. Okay.
You know.
We are looking.
So.
We have another question. Yeah, sorry.
I don't know. I agree. It's very distressing.
Yes.
I mean, this,
yeah.
you don't like to have something that's been so stable for years and years and years suddenly
Yes.
misbehaving.
Yes.
It's really very distressing.
Yes. Yes. Please go ahead with your questions. Yes.
Dr. Halstead, thank you for your lecture. It's quite an honor to attend your lecture here in Brazil. I would like to ask you a question about any similarities that you will find between the dengue virus and the yellow fever virus regarding this question. Why the yellow fever virus has never reached Asia, because dengue and chikungunya virus are all prevalent in India, in the Indian continent. But what about this this simple question? Is there any similarities in the genome between these two viruses that could explain why the yellow fever virus has never reached the Asia? And another question also, Dr. Halstead. I'm curious about your current work in monkeys, in the NIH and Rockefeller.
You've read that there are 14 Chinese that acquired yellow fever in Africa and were hospitalized in China. So the magic event has actually occurred. It just hasn't occurred as an epidemiological phenomenon like chikungunya or reaching the east coast of Africa, at which time it goes across the Indian Ocean very, very readily. I've been thinking about this for a very long time, and I think my answer is the only one that makes any sense, and that is that the Central African zoonosis, which is not capable of urbanizing, essentially it's essentially a buffer from the West African yellow fever ever getting to the East Coast, because there isn't any sort of normal progression across the land. We've all been terrified once the jet airplane was invented that somebody from West Africa is going to get on a plane and go to Asia. Well, it's happened. The Chinese, or at least 14 Chinese, but fortunately they all landed up in hospitals and cities that I don't really know where they were all were hospitalized, but at any rate, it didn't start a yellow fever epidemic in China. So the phenomenon still goes on. You know, Zika has made that transition from an African zoonosis to Asia no problem. We have Zika not from Africa, it came from Southeast Asia. So it's made that journey. The reason why I thought it was sort of I don't want to call it cute, but it was sort of interesting that when you study the history of yellow fever vaccine, you realize that what Max Tyler saw was little by little he was getting adaptation, passage after he was very insightful. And that same sort of adaptation must have occurred outside of a laboratory when urban yellow fever came to the Americas and then jumped into the sylvatic cycle. We don't know when that happened exactly, but virus has now been passaging for hundreds of years, and the virus is coming out of that passage is not urban Aedes aegypti transmitted yellow fever. It still causes disease. Sure, it's still yellow fever, but it's lost something in its passage. And the question I have is, what has it lost, and can we figure that out?
Yeah, thank you very much. Oh, Marcus Freire, last question, Marcus.
Here comes Marcos.
Yeah.
Halstead, congratulations
Please.
for your
Close to the
talk.
microphone.
I think it was, I love the yellow fever history. But my question is about another virus, another flavor virus that is Japanese encephalitis virus. Same way, we never had Japanese encephalitis virus in America. Then what is the explanation? Can you explain why we never had? Because it's about the same. You have the vector, you have the pigs, you have the humans. It never happened. Then the question that we have for yellow fever, why not never have in Asia yellow fever? You have the same. Why not Japanese encephalitis here?
Yeah, well, it's easy to ask the tough questions, right, Marcos? Figuring out the answer. Well, in a way, you have only that one endpoint. You know, yellow fever is a much more complicated virus than Japanese encephalitis. And one of the things that you have to realize about Japanese encephalitis is that it's a very rare event. If I don't know how many people here are flavivirus negative, but if I took 100, well, in this group it might be 40 or 50, but if this was Asians in the audience, it would be 300 flavivirus susceptible individuals you have to inoculate with Japanese encephalitis to get one case. So it's not like yellow fever where, you know, at least the susceptible population is almost 100% at risk. Then yellow fever has these sort of two different, you know, there's a visceral tropism and kind of a separate neurotropism, whereas JE only has neurotropism. At any rate, Dr. Yu did lots and lots of experiments in which he tried to cause the vaccine virus to cause encephalitis. It was never. We did a very it's wonderful to work in China. I went with Dr. Yu to the Department of Epidemiology. That turns out in China, epidemiology is a state secret. So I was only able to get access because I was with the Chinese and we essentially had clearance. But the amazing thing about China is that they actually follow things very carefully. And Japanese encephalitis vaccine that Dr. Yu developed was initially given to the Chengdu production facility. And the Chengdu production facility would produce a certain amount of vaccine, but it would only go to certain provinces. So we actually were able to figure out we knew when the vaccine was given, at what provinces it was given. And so the question we could ask was, when this vaccine is given to millions of children, does it ever revert? Does it ever cause Japanese encephalitis? And the great thing is that the vaccine was always given on this campaign schedule, always in the months of February or March. And Japanese encephalitis in real life occurs in July, August, and September. So the vaccine is given in February and March. So if there was any vaccine-caused encephalitis, it should have occurred in February and March. And there was no case in millions of doses. So we felt very confident that something that you couldn't possibly do in experimental animals, that real human beings were telling us that this vaccine just simply does not revert to cause encephalitis.
Thank you, Dr. Scott Halstead. Amanhã nós vamos ter outra vez a apresentação dele sobre dengue, vacina de dengue e coisas relacionadas, e ele pode voltar a falar sobre febre amarela. Just to tell about tomorrow your participation then. E uma outra coisa, agora na abertura eu tive um lapso de memória para dizer de Oswaldo Cruz, prêmio de Oswaldo Cruz, Carlos Chagas e Evandro Chagas, e também dos novos talentos, né? Sérgio Aroca, Alcides Godoy, desenvolvedor da vacina manqueira, e o nosso Henrique de Azevedo Pena, que participou no desenvolvimento aqui da vacina febre amarela, junto com Hugo Schmidt. E agora, para finalizar, você, então, tem outras informações, não é isso? Amanhã, para dizer que amanhã começamos 8h30, 8h30 com a apresentação dos posters.